Dear students, now you can see we are having an oscillator and a stretched string. If oscillator oscillates, then corresponding to half oscillation in the oscillator, an upper wave pulse is generated and it propagates along the length of the string. The phenomena of wave production we have just now discussed in the previous section. Corresponding to each half oscillation, a wave pulse is generated and it is propagated along the length of the string. So, students, now you can see that if the oscillator completes its one oscillation, it produces two wave pulses. One is the upper half, other is the lower half, and it is composing a wave. And this distance which the wave travels during one oscillation we define as one wavelength, which consists of one crest and one trough. So there's one crest and one trough, which is corresponding to two wave pulses, is basically called a wave. And each wave is emitted corresponding to one complete oscillation of the oscillator. Now we are going to discuss how the wave pulses forms a continuous wave train. Let's see that. Here, if the oscillator continue to oscillate, we can see in this situation for continuous oscillation, correspondingly continuous wave train is produced. Wave train is nothing, just waves generated one after another. Here you can see a small particle P which is in the path of wave, which is just a particle on the string. It is just oscillating up and down, and correspondingly the wave is propagating energy in the forward direction. This is what actually happening, that every medium particle is oscillating at its own position in such a way that phase as well as energy propagates.